6.1 Part 2. The learning target for this lesson, that you can solve systems of linear equations using matrices and Gauss Jordan elimination. So in what we did in class, we looked at Gaussian elimination, where we were trying to get the triangle of zeros in the lower corner. So now we're going to add to that, for it to be Gauss Jordan elimination, we want not only zeros and then hopefully ones, but we want to make, I'm going to go, not where it says assignment day one, I'm going to go to example 4. This was solved using Gaussian elimination. We're going to skip this one for now. We'll come back to it. For Gauss Jordan, our goal for Gauss Jordan elimination is to get the same zeros we got before. We're going to look at a 3 variable system. In the end, we want ones along this diagonal. We don't want to do that though until we get all the zeros first. Because you'd like Gauss, we're going to get our 0 here and our zeros here. We're going to repeat the Gaussian process. Then we're going to get zeros here. So this is the first zero you guys practice getting. Then this one, so 0 sub 1, 0 sub 2, 0 sub 3. This will be 0 sub 4, 0 sub 5, and 0 sub 6. So those are the order that we need to get. So just like Gaussian, we're going to do the same thing. And then once we have all of those zeros established, we got to get 3 more zeros, and we make all of these ones. And doing so, instead of having a coefficient of x, y, and z up here, we'll just have x equals whatever numbers here, y equals whatever numbers here, and z equals whatever numbers here. And so for this reason, we haven't talked about this before, but Gaussian elimination, where you have the triangle of zeros, but you still have to go back and substitute, that is called row echelon form, because you have to then go back and do substitution. This one, because it's also row echelon form, but because you don't have to go back and do substitution, it's also called row reduced echelon form. And we'll talk more about that in class when we meet again. Let's take a look at a basic 2-variable system. This is a little bit easier. We're going to start out by doing Gaussian elimination, and then we're going to work on getting these other zeros. So in my initial system, I feel like we've done this exact one before. I have 1, 1, and 2. So my first task is to get 0 here. So just like Gaussian elimination, we're going to do our new row 2 will be row 1 plus negative 3 times row 2. Negative 3 times, here's row 1. Negative 3 times row 2 is this. So I end up, remember, I've locked row 1. Now I have 0, negative 12, negative 6. Nope, negative 12, because I have to add. So there is, now I have triangular form. If I were just doing Gaussian elimination, I would divide by negative 12, divide all of these by 3, and then I'd solve. I'd have 1, negative 3, negative 2, and 0, 1, 1. I'd have my answer for y. I'd plug it back into substitution. Now, right, in Gauss Jordan, I need to have a lower triangle of zeros and an upper triangle of zeros. So what that means for this one is I need my 9 to be a 0. So to look at these two, well, right now, if I can actually reduce the top, it makes it a little simpler. So right now, I'm just going to replace row 1 with 1/3 of row 1, or dividing row 1 by 3. 1, negative 3, negative 2. And then I have this as 0, negative 12, negative 12. So all I did to do that was now make it a little easier to get this to these three opposites. I'm going to do 4 times row 1. We're going to new row 1. We are going to change row 1 because we're targeting this now instead of the negative 9. I'm going to do negative 4 times row 1 plus row 2. Get my new row 1. So I've locked row 2. Not doing anything with that right now. Row 1 times negative 4 is negative 4. positive 12, positive 8. When I add those together, here I get 6. Here, or not 6. Here I get negative 4. Wow, it would help if I do the right ones together. Here I get 0, which is what I was going for. And here I get negative 4. So now we've pretty much gotten the lower triangle and the upper triangle like we were looking for Gauss Jordan. But I actually want this entire diagonal to be 1. So I just divide row 1 by negative 4 and divide row 2 by negative 12. And I end up with 1, 0, negative 1, 0, 1, 1. And there's no more plugging in and substituting. My answer to x is negative 1, and y is 1. So the inconvenience of Gauss Jordan is I have to get the additional zeros. But the convenience of it is I don't have to go back and substitution. Once I've done all my elimination type methods, I will get the exact values for each variable. I'm going to try this for a 3-variable system next. All right, so I'm going to leave this in the order it is. I could have moved stuff around, but I don't want to. I've got 1, negative 1, 1, 0, negative 1, 2, negative 3, negative 5, 2, negative 3, 5, 8. All right, so now I am going to just do Gauss for now. I'm going to do the regular Gauss. I'm going to target this, then this, then this. The nice thing for this one is, again, I'm locking row 1 and row 3 because I'm targeting that right now. And I'm only allowed to change 1 row at a time going from matrix to matrix. Nice thing with this one is I can just add row 1 and row 2. I can do that right here. So I've got 0, 1, negative 2, negative 5. All right, now my next target is this. So I'm going to do negative 2 times row 1 plus row 3 to get my new row 3. Again, I am locking row 1. Since I'm trying to change row 3, I'm locking row 2 for now. So I'm going to do negative 2 times row 1 would be negative 2, positive 2, negative 2, 0. Adding these up, I've got 0, negative 1, 3, 8. So I'm just doing Gaussian right now. I almost have my lower triangle of zeros. To get my next matrix, I'm going to lock row 1 and lock row 2 again, because I want to keep those exactly as they are for now, until we get to the Jordan part. I want this to be a 0, so I'm going to get my new row 3. All right, so I am going to just get my new row 3 by adding row 2 and row 1, or row 2 and row 3. So I'll have 0, 0, that was my goal, was to get this 0, 1, 3. If we were just doing Gaussian elimination, we would be done. We've got the triangle of zeros down here. Look, we've even got a row of 1s along the diagonal, which is awesome. This is like as easy as it gets. But we need to now target, so we make our way, it's kind of like a clock. We make our way counterclockwise around in terms of getting the zeros. So I did this one first, then this one, then this one. I now need to target, would help if that's negative 2. I need to target this one. I need this to become a 0. We'll look carefully at the other ones. If I use the top equation to get this to be a 0, that's great to get a 0 here, but then I might undo this 0. So I need to use the middle and the bottom rows so that I don't lose my 0 here. So I'm going to do 2 times row 3 my new row 2, is 2 times row 3 plus row 2. So that's going to give me the following. I'm going to keep row 1 as it was. I'm going to keep row 3 as it was. Row 3 is perfect. I have locked that row down now because I don't need to do anything else to row 3. I've got 0, 0, 1. That is perfect. I already know what the answer to Z is. But row 2, I want to get a 0 here. So if I do 2 times row 3, I have 0, 0, 2, 6, plus row 2, which is 0, 1, negative 2, negative 5. This will give me 0, 1, 0, 1, which is even nicer because it's rare that I get a 1 here, but now I have that as well. My whole goal was keep these as zeros and get this to be a 0. Going to repeat elimination processes, or processes, depending on where you're from, to get a 0 here, and then my last 0 will be this one. Well, to get this one, I could use the middle row, but it's going to be hard because I got a 0 there. I'm going to use the bottom and top rows. So this one I used rows 2 and 3 to get this 0. It's really important right there. You already know what to use to get these zeros. To get this one, we have to use rows 2 and 3. So now, to get this one up here, I'm going to use rows 1 and 3. Using rows 1 and 3, I'm going to do row 1. My new row 1 will be row 1 plus the opposite of row 3. So row 1 was 1, negative 1, 1, 0. Row 3 is 0, 0. I'm changing the sign, negative 1, negative 3. This gives me my new matrix of, changing row 1 now. So we locked it before for Gaussian, but now that we're trying to get a 0, we're changing that row, which means I can't change row 2, and I can't change row 3. They're exactly what I want them to be now. So my new row 1 is 1, negative 1, 0, negative 3. We are almost done. We have worked our way. For Gaussian, we got these 3 zeros, then we got this one, now we have this one. Our last target to get the upper triangle is this one. And if you can't see which row I'm going to use, I don't want to use row 3 because if I multiply this by something, I'll get it out, it'll lose the 0. I'm going to use row 2 because I have 2 zeros here and it will only change this number. And what's convenient for this particular one is I can do my new row 2 getting a 0 there, or my new row 1 to get a 0 there by doing row 1 plus row 2 because these two numbers are already opposites. Doesn't always work out that way. You'll see that in the next example. So my new 1 will become 1, 0, 0. Negative 3 and 1 is negative 2. And I have locked the other numbers, which were 0, 1, 0, 1, and 0, 0, 1, 3. What's nice is as long as I don't make any errors in multiplication or addition methods that we use, our elimination type methods, when I'm done, I'll know the exact answer for X, I'll know the exact answer for Y, and I'll know the exact answer for Z without having to do any substitution. Now sometimes we don't get ones here. It's not a perfect system and we may get fractional answers, but we know a number here. Maybe this number was 2. Then I would divide this and this by 2 and I'd have my answer for X. Let's take a look at this last 3 by 3 as an example. I am going to shift this to row 1 because I like that it's a 1 there. You don't have to do it that way, but I'd like to. And you may come across some where you want to shift the rows throughout. Makes it a little less clean, but it can be done as long as you only change one thing at a time as you create your new matrices. And I'm not sure why in the world I put the variables on them. That was not my intention. Right? We should be putting it as an augmented matrix so we don't have to think about the variables. I'm not going to rewrite it though until I get my next matrix. So, just like Gaussian, this is my first target. Right? We wrote down the steps before for Gaussian. So step 1, we're going to get that first 0. We're going to get row 2, column 1 to be a 0. I'm going to use row 1 and 2. You don't have to use that. This is the one opportunity where you could use these two if you really wanted to. So I'm going to keep my row 1 as is, which right now is -1, -2, -4, -1, and my row 3 as is for now. But my new row 2 will be 4 times row 1 plus row 2. So I'm going to do that math right here. I've got 4 times row 1, so -4, -8, -16, -4 again, and 4, 9, 16, 2. I'm going to have to show the work so I don't screw it up. So I got 0, 1, 0. Hey, that's really nice. I'm going to try to leave that exactly like that. It's rare you get the other 0 here. But since we did, we'll leave it. And then this is -2. So I'm going to lock that row down and never change that row now that it worked out so conveniently. But usually we get the 0 after we got the lower triangle. Well, my next 0 to target, because we're going for Gaussian first, is this one. So step 2 is to use row 1 and 3, get a new row 3 with that 0 for row 3, column 1, 0, using row 1 and row 3. So I'm going to do 2 times row 1 plus row 3, which means I'm going to have -2, -4, -8, -2, and 2, 4, 9, 9. This is going to give me, again, we locked row 1 for now. We're locking row 2 forever. And this will give me 0, 0. Oh, that's even nicer. It's rare that you get that right away. Normally we have to do another Gaussian. All right, so now usually we would do step 3, which would be to get the row 3, column 2, 0 using row 2 and row 3. But we don't have to. We get to skip that here because it's already there. Lucky us. Step 4, this is where we get to Gaussian. Step 4, we would aim for this 0, but it's already a 0. To get that 0, we would have used row 2 and 3. We'd use row 2 and row 3 to get row 2, column 3 equal to 0. But it was done, like by coincidence, it worked out. So our next 0 to target is this one, this -4. So step 5, so in this particular problem, we got to skip step 3 and we got to skip step 4, which is kind of crazy. Step 5, we're going to use the same methods, but using row 1 and row 3 to get row 1, column 3 to be a 0. So to get my new row 1, these two are now locked. I have my lower triangle is 0s, I have a 0 here. My new row 1, to get that 0 there, I'm going to do row 1 plus 4 times row 3. 4 times row 3 is 0, 0, 4, 28. When I add those, I get -1, -2, 0, 27. So let's do this up here because I might need more room. This means that I now have a new row 1 of -1, -2, 0, 27, but the rest stays the same, 0, 1, 0, -2, 0, 0, 1, 7. Step 6 of using elimination methods. We're going to use row 2 and row 1 to get a 0, to get row 1, column 2 to equal a 0. So to do that, I'm going to do my new row 1 is row 1 plus 2 times row 2. Row 1 is -1, -2, 0, 27. 2 times 2, or 2 times row 2 would be 0, 2, 0, -4. When I add those, my new row 1 is -1, 0, 0, 23. My row 2, I'm leaving locked. My row 3, I'm leaving locked, and even if I weren't, I cannot change more than one row at a time. So now I'm almost done. I have my lower triangle of zeros. That was the Gaussian steps, steps 1 through 3, but we were able to skip step 3. I have my upper triangle of zeros, step 4 through 6, but we were able to skip step 4 because there was already a 0 there. And now I just need all of these to be 1s. Well, to make them all 1s, just going to divide this by -1 to change the sign. And I have my answers. X equals -23, Y equals -2, and Z equals 7. So as an ordered triple, -23, -2, 7. We will have further examples of this and lots of practice with it in class. But just like for systems of equations, when you learned it in Algebra 1, you had to be able to do graphing and elimination and substitution. For solving multivariable systems, you can't just do Gauss. You're going to have to be able to do Gauss Jordan. So in class, we'll do some problems where we review these steps, but you can see how it goes like a clock. Get this 0, this 0, this 0, this 0, this 0, this 0, and then get these all to be 1s, and you'll have your answers. You will not have to do any substitution. This concludes the video examples for 6-1, Day 2, using Gauss Jordan elimination to solve linear systems of equations. Have a great day.